Hello everyone. Today we will work on a Jupyter notebook, and today we will explore scikit-learn, and in this tutorial we will utilize logistic regression model as well as the PCA to and we will work on a digits data set in the scikit-learn. So let's start. The objective of this tutorial is to explain basically the functionality of PCA, what is the advantage of PCA, and how we can reduce the uh, features uh, using the PCA. So let's start. First, we'll import pandas as PD. PD. And then from sklearn, datasets, import load underscore digits. This is a digits dataset. And we will store this dataset into datasets is equal to load underscore digits. Keys. Hmm. So this is basically the data uh, set keys. We have the data, we have the target, we have frame, feature underscore name, and the images and the description. So basically in this data set we have about 1797 rows and 64 columns. So let's move forward, explain further. Let's look at the dataset dot data dataset dot data 0. So this is the first data set, first row. So on the same, like we can write down like 1700. So this is 1700 row, and these are 64 columns, right? So in this, this is in a single dimension. Let's shape it to two dimensions to present in the graphical manner. Data 0 dot reshape. So now we converted the same into 8 by 8 columns, 8 in the rows and 8 columns. Basically, these are the 64 features. Let's say if we write down here 1700, so this is a 1700 data. So now we will visualize this in a matplotlib. So from matplotlib import pyplot as plt plt, and then matplotlib inline gray. I want to give the colors to these graphs. Matte show. Data and the which row we, let's say we are working on the 1700, let's put the 1700 here. Dot reshape 8 comma 8. So 8 by 8, so basically we will convert this into graphical manner. It will show the digit, what digit is the 1700. This spelling mistake. So basically this is the number 1700 digits. Same we can, you see this is this digit is in the same number of 1700 row is in a single dimension, but we convert reshaped into 8 by 8 dimension. These are the figure numbers. But when we show that into the pie plot, it's this. Similar, we can change it to 1, 1, 1. Run that. Okay, so this is now this is 1. So basically, that's how it shows that we don't know what this number is. This is the first row of the column. So we'll figure out later on. Let's move next step. We'll import numpy as np. Numpy as np, and then dot unique dot target. These are the target numbers. Let's see. So these basically these are the numbers in this 1700 rows. Either it will be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are the targets. So and this is the data. Now we'll create a data frame dot create dot ed dot data frame is equal to pd dot data frame. Dataset dot data comma columns is equal to features underscore name. Now tf data frame dot head, like top rows. So basically this is the data set, and these are the uh, 64 columns. These will be 64 columns, since there's a lesser space, so it's showing up to that. But these are basically top 5 rows, 1, 2, 3, 4, 5 rows, and these are the top 5 rows and 64 columns, right? For in each row, for example, this is 0 row, there are 64 columns, right? Or 64 features. Now let's move forward. At the end, it will all make sense that what we are now doing is just a practice, and once we do the practice, we will learn to experiment with the different data sets. Now we can describe. Let's see. We can see tf dot describe. See, in this, it will describe the data set. For example, in the first row, all are these zeros, and in the second and in this column there is a maximum 8 and then minimum mean. This is the mean, this is standard deviation, and this is the minimum is 0. So if you would look at that, you will if we see that there are 16 are the maximum digit, maximum number, and the 0 is the smaller. Now that is the description of this data set. These are the numbers we have. Now let's uh, x. Let's say x is equal to df is equal to data frame, and y is equal to dot get target. Now x is this data frame, df, so x is this data frame, and y is the target. Let's see what is y. So y, you see we mention here, these are the array of y. So these are the numbers in this targets, like what these are. These are the number. For example, if we look at the array 0, let's look at this. If we run it into 0, you see this is 0. So 0 is basically 0. So these are the targets, like what they are. So we have to uh, move accordingly. Let's move to the next step. So in order to run this, we have to scale this data, because these are the maximum 15 and 16 and 0. There is the numbers are different, so we can run feature process this into standard scaler, scale the data from sklearn dot pre-processing code standard scaler. Let's declare a variable. Scalar is equal to standard scaler. x underscore scaled scaled is equal to scalar underscore transform let's run that. And now we'll scaled is equal to dot fit underscore transform x. So basically we are transforming our x data frame x, and then so what have we have done here is that basically we scaled our this data set where these figures to 1 to minus 1 to 0 like values, right, to be used in the PCA and in the so this is what we have now to be used in the modeling machine learning. Now we'll from sklearn dot model underscore selection import the train underscore test underscore split. Basically, we'll now split the data train underscore test underscore split and now here we will have x underscore tra and train comma x underscore test comma y underscore tra and train comma y underscore y underscore test is equal to train test split and the data we have is x underscore scaled, like we will use this data set x underscore scaled, which we scale from here. Now it's called as x underscore scaled, and we want comma y comma test underscore size is equal to 0.20, 0.20%. So 20% we need a test data. We split the data into 20% test and comma random underscore state we will use 30. Basically this parameter is used to so that we will have the same result. Okay, now let's first we will run this one. Okay, now we will use the from sklearn from sklearn we are using the logistic model from linear linear underscore model, import logistic regression. From here we will import logistic regression, and ODA model is equal to logistic regression and ODA model dot fit x underscore train y underscore train, and then we will score this model.score test, comma y underscore tpst test. So basically what it will do is we are importing the linear from the linear model, importing the logistic regression, and here we use the parameter model is equal to logistic regression and the model dot fit. So we will pass all the training data, which is 80%. You see here we say 20% is the test data and the 80% will be the training data. So it will the model will use the 80% of the data and train this model, and then this model will utilize the score on the test data. Then it will the test data will pass through the model and it will score, right? So in other words, we train the model logistic regression by utilizing 80% of the data. Once a model had seen the 80% of the data, then we it understand that what the data is about, right? Then we use the same model.fit, and then we will score on test. We will 20% of the data will be used to see if this model works or not. Let's run that. So basically we got 97% results. So this is at this point we are using all the 64 features of the data set, 64 features. Now here comes the PCA. Now we'll utilize the PCA and see how we can reduce the 64 uh, features to lesser features. Let's do that. Now we'll use from sklearn from sklearn dot decomposition decomposition import PCA. So we are importing the PCA. So now PCA is equal to PCA is equal to PCA make it smaller, and then here there's several ways we can utilize PCA. We can use, like, we can say the PCA that we want instead of using all the 64 features, we can use 10 features or 20 features or top 5 features. But here we will utilize 0.95. So here what we are saying is get the 95% of the information from the data set and reduce it and reduce in a way that we will get the 95% of the information from the data set. We don't want to miss a lot of information, right? So let's now we'll use x underscore PCA is equal to PCA dot fit PCA dot fit underscore transform x. Now see what we get. You see, when we use the from the sklearn, we could import PCA, and then we use PCA to get the 95% of the information from the 64 features, right? So x underscore PCA is equal to P when it fits the data on x, then we shape. Let's look at the shape. Now we have the 1797 and 29 features instead of 64. We have, you see, we here we have the 64 features. Now we have the 29 features. So we reduce that. Now let's run again. Now let's run. So now we have 29 instead of 64. We have 29 features, and let's move to the next step. Now we'll see the variance. We'll create another video, basically mathematical point of view for the PCA. But right now we will utilize the tool which is given in the sklearn to explain how these tools are very can be used to reduce the lot of features into lesser features. Now PCA.explain variance underscore ratio. You see in the 29, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 26, 27, 28, 29. So basically these are the, now we have 29 features, and in these top 40 variances are like the one feature first top are 14%, then we have a 13% variance, and then we have 11 and so on, right? And we can see the PCA.nm components. Twenty-nine features, right? Now move to the next step. Now we'll run this again. PCA. So these are the target variables, right? Is equal to x underscore PCA, comma y. Y is a target variable, and test on same thing. Test underscore size is equal to 0.20%, comma random underscore state is equal to 30. We use the same. And model is equal to logistic regression. Logistic regression. MODEL model dot fit. Now we'll use x underscore train PCA and y underscore train. Model dot score. Now we'll use model dot score x x underscore test PCA comma y underscore test. Now let's run. Now we will use the PCA data. This one, you see, with the 29 features. So there is a smaller difference. Here when we use the 64 features, we got 97, but when we reduce these to 29 by using PCA, we got the 96 point, almost very close result. So okay, so we got 96% result. And let's use this one. You see, we have now 29. So these are 29, and the same we have these are the variance we accumulated. Now let's do something different. Now we'll see the data how it shows in the uh, actual versus the predicted values. So let's do that. And we'll use here to create a data frame for test data. So test and results equal to pd dot data frame actual y underscore test predicted. Basically, as we mentioned, we trained the data. Now we'll compare with the actual versus the predicted values. Let's run that. So we selected the 100 rows, or let's say top 7 rows. So in this top 7 rows, when there was actual number is 8 and it predicted true. When there was number 1, it predicted 9. So we have one false here in the top 7 rows. So we that's how that shows that when there was actual values and then we what this model predicted. And let's do something extra on that. So basically, that was the topic we covered here from the data set of the digits data set, which is available in the scikit-learn, sklearn, and we utilized this data. We loaded this data into the data set, and then these are the basically what we have here. We have the data, then we have the target, and these are the keys, the description and all that, dataset dot keys. So if we shape the original data, if we look into original data, we got the 1797 rows and 64 columns, 64 features. So we shape this data. This is the in one dimensional. These are all in, but we shape this data for the to present in a graphical way. We reshape that into 8 by 8 column, 2 dimension. So here we have 8 uh, 8 in the columns and 8 rows per digit, right? Per digit, these are the number. And when we look into that, if we graphically see this information, we will have this kind of picture will be presented here, right? And then this is the target is like these are the digits. These digits are ranging from 1, 2, 3, 4, 5, 6, 7, 8, 9, And then we utilize the data frame, and then in the data frame we have the dataset.data columns and features. So these are top uh, 5 rows and 64 columns, right? And here we use the describe that what is the what's in the data, what are the numbers. So here we have in the second column we have maximum value 8, minimum value 0, and so on. So we maximum we can see that we have 16. In this 16 is the maximum number we have seen so far, right? So we store this data frame into X, and then Y is equal to target. Target basically is the numbers. So it's in other words, X store the data set, and then Y is the target, what each uh, rows pertains to, right? For example, this column has these numbers, but we don't know what is this. But these are their targets are ranging from 1 to 9, 0 to 9, 0 to 9. Right? Then we use the sklearn to pre-process, import the data, import standard scalar, and we scale this data, and then from sklearn mode selection. So in the original data, we scaled this to utilize in the machine learning model of linear regression. And then here we have x underscore train and x underscore text, y underscore train. It will train the data, and then it will have a test data. Then we have the 20% of the test size. We utilize logistic regression for 64 features for full of all the features. Then we got the 97% result, 97% correct. Then we utilize in the next step we use the PCA for 95% of the information we extracted from the 64 columns. So it's mathematically we will create another video which will show how the PCA works in the background. But in this we will focus on the tool, how to use this tool. Where we did the when we did the PCA 95%, then when we gain the 95% information from these 64 features, so we will got the same rows but 29 features. Now we have 29 features, x and underscore PCA, and this is the information we have. So this is the variance we have. We will create another video for explaining all these. Uh, and these are the components, and then we use the y underscore test underscore pred and prediction, and we now then we compare the test data with having actual value and the predicted value, and that is the our result. So basically, this is very initial video on the machine learning, and I have tried my best to make it as simple as possible. But I think it's once we do all this practice, this all this makes sense. The most important is to do some practice, and I hope this video will be useful. And if you like it, please subscribe our channel, and in the coming videos we'll try to make it more easier to understand, and also present some mathematical background on how these PCA works. Thank you everyone, and have a great day.